Hi, and welcome to the Groninger Library first STEAM video. So today's activity is going to be shadow tracing. And this is part of our Science Explorer activities for our summer reading program. So what is a shadow? Do you know what a shadow is? Well, I'm going to go ahead and tell you a little bit about shadows. Rays of light come from a source, and we have different light sources. Today we're going to be using that great big ball of light behind me, the sun. But there are other light sources like lamps or flashlights, but we're going to be using the sun as our light source today. The sun's rays come down in a straight line, and a shadow is formed when an object goes ahead and blocks that light. As you can see, the sun is behind me and I'm blocking the light. So now that we know a little bit about what a shadow is, let's go ahead and start thinking about, do we have any questions about shadows? I know, I'd like to know what happens to your shadow during the day. Does anything change with it? So for our summer science experiments and our STEAM videos, we're going to use the scientific method to go ahead and answer some of our questions. So our first step is ask the question, what do you want to learn? So I know I'd like to learn what happens to a shadow when your light source moves. Again, our light source is the sun, so we know that the sun moves throughout the day. What happens to our shadow? Now that we have our question, we're gonna form a hypothesis. We're gonna predict what you think is going to happen. I think as our sun, excuse me, as the sun moves, our shadow is going to get bigger and longer. So we're going to see if that happens by step 3, conducting an experiment. And that's going to be our shadow tracing. So all that you need is some sidewalk chalk and a volunteer. Volunteer, come here please. So my volunteer for today's experiment is Thomas Nichols, and he is going to be our volunteer. You could use a parent as a volunteer, or you can also use an object. Just make sure your object is big enough that you could get a good shadow. So that's going to be our experiment. And we're going to test our prediction during our experiment. Step 4 is we're going to draw conclusions. What did we learn from our experiment, and how does it answer our question? So that's going to be how we're going to use the scientific method for our STEM activities this summer. All right, so we are ready to start our experiment. I have my object and I have my chalk. Now, the first thing I'm going to do is I'm going to outline where my object is standing. This is not part of the shadow, but this way I make sure I know when I come back later on, I know where my object was placed, keeping his position constant. In an experiment, you want to have a variable, which is what changes during your experiment, or what you're testing to see if it does change, and a constant, which is something that doesn't change. So I want to make sure my object, the position of my object, stays constant. So I am outlining where my object is initially standing. So I have my constant, and now I'm ready to go ahead and outline his shadow. Again, there's my light source. Remember, never look directly at the sun, but we have our light source, which is our sun. You can also do this inside with a flashlight, but we're using the sun as our light source. And now I'm going to go ahead and outline his shadow. All right, our shadow is complete. Now the time is 10:12. The time is 10:12. We're gonna come back in an hour and check to see if our shadow has moved and if any of the sizes have changed on our shadow. Because remember, our hypothesis was, as our light source moves, does our shadow get bigger? I think it is going to get bigger, so we're going to see if my hypothesis is right. So this is our 10:12 shadow. So we'll see in 1 hour what happens to our object shadow. So the time is now 11:12. It's 1 hour since we did our first shadow. I have my object, my lovely assistant, standing back in his place. Again, that's our constant. So his position is our constant. But as we can see, his shadow has moved. So we're going to go ahead, and I'm using a different color. We're going to go ahead and trace his new shadow. Okay, so, would you stand up straight, please? No, stand up. Okay. All right, just back up. So, what have we started to notice? We know that our object has remained constant, but as our sun has gotten higher in the sky, instead of getting bigger, I see that our shadow is actually getting smaller. So we're starting to see a pattern that, or maybe the start of a pattern, that as our light source gets higher, our shadow actually gets shorter and smaller. So we'll be back in 1 hour to see if our pattern keeps going in that direction. So this is all part of our experiment. So it's now 12:12 and we're back outside to see how the change in sun position has affected our object's shadow. So over the past couple hours, what could you have been doing while you were waiting to come back out and check the shadow? You could have been reading lots of books on light and shadows. These are books from the library collection that you could check out if you want to learn more about light. We're now doing curbside pickup, so have your parent get in touch with the library and you guys can check out any books that you want from our collection. But right now we're going to go ahead and check out our shadow. Come on, object. So remember, our lovely assistant is standing back in his footprints because his position has remained constant. He has remained in that position throughout our experiment. What's changed, our variable, has been the position of the sun. So we're going to go ahead and we're going to outline his shadow for the final time. Okay, come on, stop moving around. Okay. So remember our question of how does the positioning of our light source impact a shadow? So our light source was the sun. Again, we could have used a different light source like a flashlight or a lamp if we were inside, but we were using the sun, which naturally moves through the sky throughout the day. So we can see from our original shadow at 10:12 to our 11 o'clock shadow and now our noon shadow, that as the position of the sun gets higher in the sky, our shadow actually gets smaller. So my original hypothesis of our shadow getting bigger, I've proven incorrect. Our shadow actually gets smaller as our light source, the sun, gets higher in the sky. So this is an experiment that you can go ahead and try at home. All you need is an object, and it doesn't have to be a lovely assistant. It could be a stuffed animal or a toy, just anything that's big enough to give you a good shadow that you could track. You need some chalk. Now I've used different colors so it's really easy to see, but you could use the same color. That's all you need to go ahead and redo this experiment at home. All right, this is Kate the Librarian signing off. We'll see you guys next week for our next STEM activity as part of our summer reading. Bye.